an audience like this, I'm sure that everybody would agree that plastic is a fantastic material. And from a carbon perspective, so much better than glass or paper or metals. And so we have to sort out the right-hand side of the slide, which is what do we do with it at the end of its life. 40% going to landfill, 14% going to energy from waste, 32% ending up in the environment. These are the figures from the new plastics economy on plastic packaging. We all agree, completely unacceptable. So what's the answer? Well, if we summarize, the current recycling of plastic, which amounts to, I think it's being used several times today, 10%, is mechanical recycling. So we're washing it, we're flaking it, and we're turning it back into more products. So it's going to the consumer, and then it's going back to somebody who's molding it into another product. And that in and of itself is fantastic. And the more we can do of that, the better. But clearly, if that was going to be the solution to the problem, I suspect it'd be a lot more than 10% by this stage by now. And so we need more tools in the toolbox. We've all been hearing it's a complex problem, it's a big problem, and we need as many tools in the tool set as we can to actually fix the problem overall. And one of the things I'd like us to think about is this thing called feedstock recycling. So first of all, I would say, it's been great to hear about, people like Ravish talking about the magnetic labels, and there's lots of new technologies coming on in the mechanical recycling. And so in our view of the future, at least 40% of plastic should be able to be recycled mechanically in years to come. Now, I've deliberately not put a time unit on the bottom, but at some point in the future. But I also see that there's a big need for what we call chemical recycling, or it's often been called chemical recycling, perhaps more accurately, feedstock recycling, and that's the taking of plastics which can't be mechanically recycled and turning them back into an oil that can be used by the petrochemical companies as the starting point for making more plastics. And that's exactly what we do. And so, theoretically, you could actually build one big facility and you could take all of the plastic that you can't currently recycle in the world to that facility, and the petrochemical facility could actually turn that material back into a feedstock and they could use it. The reason that they don't is simply because moving very large tonnages of plastic, large distances, is far, far too difficult. And so our innovation was to actually shrink the idea of a refinery down into a transportable set of modules which we can mass produce. So you get economies of scale not by making it vast, but by making it mass producible, and then having something which you can actually transport to every waste center around the world to take the plastic which isn't currently recyclable and turn it back into oil. And I'm talking about crisp packets, I'm talking about multi-layer films, I'm talking about multi-layer films with aluminium, I'm talking about black plastics, I'm talking about food contaminated, the AD material, or the stuff that comes from AD plants after you've taken the food out of it. The stuff that we all recognize, the films and all that kind of stuff, that's the sort of plastic that we're talking about here. That's all perfectly recyclable today from a technological point of view. The question is how much capacity is there to do it? And so our plant would actually take a ton an hour, and therefore about 7,000 tons a year, and turn it into about 5,000 tons of this oil product, or this feedstock. Whilst we want to do something great for the environment, it has to make very good financial sense. And so this machine would have a typical payback of about 3.5 years when oil is at $50 a barrel. Now, currently oil is at a lot more than that, and so you can do the maths on the payback. The output, slightly complicated slide, but it's a wide distribution of different hydrocarbons. We started looking at it as fuels, as have a lot of people. We've basically ditched that idea because whilst it's actually technically very, very feasible, it's not circular economy. And so we want to go above the line and actually look at things which are recycling. And so we've got waxes on the right-hand side, which at the moment we choose to make because they're very, very valuable. We don't have to make them. We could turn it all into what you call cracker feedstock or steam cracker feedstocks. So steam crackers start with either gas or with liquids. We're talking about the liquids here, and any steam cracker around the world which is making polymers can actually run on this kind of material. And so where are we? Because it sounds like, it's too good to be true kind of analysis. And so, a lot of people say, well, a lot of people have tried this. There've been all sorts of problems. And you're absolutely right. You can go back to Warwick University, which is where we actually span out of. And there were tests going on with dubious kind of results. In 2013, we formed a company. In 2014, you can see we were at laboratory sort of scales. And then we started scaling up. And, this is the plant when it was assembled at our manufacturing facility. And then we took it out into a waste environment and we started making barrels of this stuff that we call plaques. A lot of people ask me, why is it called plaques? And it's a slightly waxy hydrocarbon. It used to be plastic. Plastic, wax. There's limits to engineers' innovation. But of course, we wanted to actually make it into modules. And so we said, well, let's actually just take this to the next stage. And so here's a photograph of the first 2 modules actually leaving the production line or our original manufacturing facility. And this is actually then taken to the facility that we have in Swindon in the UK, where this plant is actually processing plastic today of all sorts of different kinds and colors and types into this material, which goes back to the steam crackers. And so this is actually, there, and anybody that wants to come to Swindon and come and see it, you'll be very, very welcome. But that doesn't solve the capacity problem, because this plant is actually doing a few thousand tons a year. This is our pre-production facility. And so the first of our production facilities actually is due to come on stream next year. And so we've literally, in the last 8 weeks, moved into this building here, which will actually allow us to put an assembly line together so that we can actually mass produce these machines so that we can deploy them around the world. We intend in the future to have more than one assembly facility. This particular facility will go to 200 machines a year. And so that's supporting our aim of actually producing 7 million tons of plaques in the year 2027. So if you remember the math, 7,000 tons into 5,200 tons of oil, and you work backwards, that's about 10 million tons of plastic recycling capacity that could be built for 2027. And so that could be more. We're very happy to work with other partners who could actually mass produce these under license as well, so that the world has many, many more of these types of machines, so that the vast majority of plastic, 90% of plastic today, can be recycled. We just need to go and build the capacity. And so we would welcome anybody that wants to join us as investors or employees or even people who want them on their site. We're very happy to engage in the conversation. Thank you very much.